You type a website address and you push down on the Enter key. It is one of the most repetitive actions in our digital lives. We have been conditioned to expect an immediate result. If a blank screen hangs for longer than 2 or 3 seconds, we start to get visibly frustrated. That expectation of speed is an illusion. A seamless user experience masks a sequence of operations taking place across multiple physical locations in a fraction of a second. To see how it works, we have to freeze time. We need to stretch out the exact interval between the moment you press that key and the moment the pixels populate on your screen. Dissecting this hidden millisecond tracks the coordination required between your hardware and servers located halfway around the world. The process begins locally. Your browser instantly checks its own cache, a small reserve of memory, to see if it already knows the specific IP address for the website you requested. If the address isn't in the cache, the browser sends a request to the Domain Name System, or DNS. This diagram shows the translation process. A human-readable URL enters a central server hub, which returns a numeric IP address. That IP address identifies the physical server on the globe hosting the site's data, providing a specific destination for the next request. This initial lookup demonstrates how the internet relies on geographic routing just to locate data before any content is ever retrieved. Finding the server is only the beginning. Before any data can be exchanged, the browser and the server must establish a secure connection. The two nodes execute a TLS handshake, a cryptographic exchange where both sides verify identities and agree on the encryption method. Once this secure tunnel is active, the browser finally sends an HTTP request asking for the web page data. The workload now shifts to the remote server. Simple websites might only require the retrieval of a static HTML file, but modern platforms are significantly more demanding. In milliseconds, the server queries databases, checks user permissions, and runs back-end code to generate content specific to the user's request. The server computes this data package from scratch, integrating database results and user-specific logic into a unique response for that exact moment. The server finishes its processing and sends the raw data, HTML, CSS, and JavaScript, back across the network to the user's browser. The browser now acts as a construction crew, parsing the raw incoming text to build the page structure. This cascading tree represents the Document Object Model, or DOM. This structural blueprint is assembled directly from raw HTML. The browser then applies CSS roles to determine the visual layout, while executing JavaScript to enable interactive elements within that structure. Finally, the browser calculates the precise position of every element and paints the actual pixels onto the user's monitor. This process converts thousands of lines of raw text into a functional visual interface, completing the transition from code to interface in milliseconds. The cache check, the DNS lookup, the TLS handshake, the database queries, the DOM assembly, and the final pixel painting. This entire sequence of global communication and local computation finishes before your finger even lifts off the keyboard. Modern browsing functions through the real-time generation of these environments, tailored to the user's specific credentials and device. This speed is maintained by background optimizations like content delivery networks, which store data geographically closer to the user, and lazy loading, which prioritizes the elements currently on screen. This high-speed coordination across global infrastructure is what makes the modern web's complexity feel entirely transparent to the user.